Hello, and welcome to the airline aerospace reliability world. And this is understanding airline reliability for beginners. And today's subject is what airline aircraft operational reliability is. Small disclaimer here. If you need any type of legal aviation business related advice, please contact your aviation authorities directly. And also, before we start, I would like to mention that all reliability discussions are from high-level perspective in these presentations. And if you wish to understand more, probably you need to take some aviation aerospace university courses. Let's begin. First, let's understand the stages of reliability from design to the operation, from the end for whole life. Okay, and for this reason, let's group reliability tasks. From classical aviation reliability point of view, there are minimum 6 high-level tasks of reliability. All these tasks are serving product safety and reliability, starting from the product material and weight to all the way to the operation. But I would like to mention also here that all tasks are important. But for better understanding, let's simplify tasks and sort them into 3 groups. Depending on task or TRD, TRD means here technical requirements, documents, it can be grouped based on the different priorities. So here is our 3 groups. Let's describe the tasks in the group 1. So we have bridge between old and new system, product, items, elements, LRUs. Group 2, we have bridge between unit, elements, items, and unit, system, product. And group 3 tasks I described as information based on operation. So we have real life data. And of course, in the middle, we have aviation, aircraft, reliability. Probably I need to add here safety. Okay. Let's go to the group 1. The group 1 I called a prioristic. Model is built on historic data, no new product information available, product doesn't exist. So first item is product doesn't exist. So we are just starting developing TRTs, specifications for a new product. Number 2 item I put historical data, and most items, characteristics, reliability, cost, maintenance are based on old product system, experience, and performance. Let's say we have BPCU, bus power control unit, BPCU, and we have based on our, let's take reliability, right? Because since we are here, since we are talking here about reliability, 10,000 flight hours. MTBUR, for example, MTBUR. Okay? Now for the new product, TRD, we have, let me call it just B. We have maybe C1, maybe 2. We have 20,000. So a TRD requirement is 20,000. Okay? And item 3 in group 1, we have statistical data. Let me explain here. Mathematical probabilistic model in most cases of the product system is built based on statistical maintenance data of the old product system experience and performance. What does it mean? So, from let's take BPCU, right? So, old product tells us our reliability or MTBR is 10,000. New product technical requirement is 20,000. Sometimes it's not enough just to change a couple elements, for example, diodes, resistors, transistors, or whatever, to reach this number. What we need to introduce here new technology. Okay? New technology to reach these 20,000 flight hours. And appropriately, and I think this is clear, that if we have new technology, then all models, especially from reliability perspective, reliability models, they won't work. They simply won't work. Okay? Now, group 2. Group 2 is all about new product, and it's all about design and experiment. So product exists as a model, no real operations data available, real life operation data available, all data based on tests and experiments, and also some mathematical models. Okay, I have to put here math models. Okay, so and item 1 is in group 2 is elements items units. So end product for the group item 1 is building unit. And what does it mean? So all information about product items elements are based on history, also from technical specification and TRTs. And reliability probabilistic models are based on the units, LRUs, experimental testing data. And also I put here some additional statement, because in some cases it works. Old item element LRU product experience. Okay. Item 2 in group 2, right? We have unit. Now we build the unit. Everything is okay. Everything is based on TRD, right? So now we are taking this unit and inserting into the system, right? And from system, what we are doing, we are integrating into the product. Let's say unit was BPCU. System is, since this is electrical element, bus power control unit, LRU, we put here in 8824, which is electrical system. And the product, in this case, is aircraft itself. Now, I would like to go for group 2, since group 2 is all about new product, right? I would like to go a little bit detail level for this reason. Let's open our black screen. Okay, so before we start, let's put some structure here, right? Okay, we have item, element, LRU, unit. Let me call it block, not unit but block. TRD. So I have to put here TRD, right? TRD. And we have also LRU system aircraft TRD. Okay. These two blocks are part of our structure. So what we are doing here, we put some feedback also, right? And we have here decision making sum. And let's say let's build some simplified reliability model. Okay, maybe you'll understand what we are building. Okay, this is another item. It's very simple. Okay, all these numbers and all this structure is from my head. Okay. Okay, and this way. Okay, let's do the connections here. This is parallel. Let's put some failure rate. For this one will be lambda 1. For this item will be lambda 2. Let's group this item here. Okay, call it lambda A and lambda A1, lambda A2, and here let's say this is lambda 3. Okay, let's say this is, okay, let's go to the BPCU level, element level. Okay, and let's say the requirement is the probability that item is working is 995. Just numbers are from my head, okay? All these diagrams. So TRD in this case for reliability is these TRDs are 9995. Okay? So what we have, oh, and a formula. I forgot the formula. Formula P probability equals a very simple model minus, E in power minus lambda sum, okay, and multiply by time, okay. This is the formula. Now what we have? We have specifications, okay. We have specifications for this item, and then the group A item, and etc. Let's say here we have spec, and this spec tells us that we have D1. Let's say again, I'm taking from taking all this info, all these numbers from my head. We have 2. With diode type 1 we have 2, diode type 2 we have 1, I don't know, resistors we have type 1, we have I don't know, let's say 2, etc. Okay, now what we are doing, right, we also have a list of elements, nomenclatures, based on our experience, and we are saying, let me put here nomenclature, okay, and we have here, since this is BPCU and then all these elements are the electrical elements, let me put here failure rate lambda multiply 10, let's say -6. Again, as I said, the numbers are from my head. So, and 1 over flight hours. Okay, and what we also have, we have C, which is cost